Welcome back to the deep dive. Today we're digging into something pretty big. 22 years of app security history, basically mapped out by the OWASP Top 10.
Yeah, and with the 2025 release candidate out, it gives us a really clear picture, doesn't it?
It does. We've got this data-driven story of where things are heading, what leaders really need to focus on now.
That's exactly it. You know, the top 10 isn't just a list.
Right.
It's a narrative. It tells the story of how everything changed. We went from, like, monoliths and simple code errors in 2003
Right.
to these incredibly complex distributed cloud-native systems we see today. The whole mindset has to shift. Forget just guarding the perimeter. Now it's about securing the entire pipeline.
Exactly. And we know CISOs, security teams, well, you're all dealing with this complexity daily.
Yeah.
So our mission here, our deep dive goal, is to boil this down fast.
Get to the core.
Yep. Get you the 3 big strategic shifts the 2025 list really hammers home. 1, infrastructure is the new attack surface. 2, the supply chain, that's your new perimeter. And 3, DevSecOps isn't some nice to have anymore. It's mandatory. It's the only way to operate at scale.
We'll definitely get into why things like misconfiguration are just skyrocketing and how these integrity failures in the pipeline, they're genuinely existential threats now.
And, getting up to speed quickly but really understanding the stuff deeply, that's key to managing all this complexity.
Absolutely essential.
Which is why we really want to thank our sponsors for backing this deep dive. DevSecOps.vibehack.dev, cloudasses.vibehack.dev, and you can find the whole suite of resources over at www.vibehack.dev. Okay, let's jump back. 2003, the beginning. What did things actually look like then? Set the scene for us.
Right, so 2003. Think physical servers in a rack somewhere. Big monolithic applications, one code base pretty much. And defense was simple. Build a strong firewall, secure the network edge. The perimeter is everything, inside, mostly trusted.
And the threats reflected that.
Totally. Very direct things, unvalidated parameters, command injection, remember buffer overflows, especially in like C and C++ code.
Right. Oh, yeah, a classic.
And security, it happened after. Developers built the thing, then kind of tossed it over the wall. Security tested it later. Very reactive.
But those walls, they started crumbling pretty quickly. Around 2010, maybe? With cloud starting?
Yeah, that was the first big crack. Cloud migration begins, and suddenly that safe inside assumption, gone. Traditional network controls, firewalls, they were kind of useless against this new elastic API-driven infrastructure, IS.
Right.
And that's when security misconfiguration really started climbing the charts. People just didn't grasp the shared responsibility model. They thought the cloud provider handled everything. Big mistake.
And then came speed, DevOps. 2013-ish, suddenly we're talking hundreds of deployments a day.
Exactly. That velocity just broke the old security model. Manual testing, no way to keep up. But the really critical thing in 2013 wasn't just speed.
What was it?
It was trust, or lack of it in new places. The list added using components with known vulnerabilities. That was huge. It signaled a shift.
Right.
We weren't just worrying about the code he wrote anymore.
Right. It was about all the third-party stuff we were pulling in.
Precisely. The software supply chain risk was officially born. We started depending on code we didn't write and, frankly, didn't always understand.
Which leads us straight to 2017. Microservices, containers, Kubernetes. The application itself just kind of exploded in pieces.
Yeah, fragmented is the word. We weren't securing a single house anymore. We were trying to secure a whole distributed city. Complexity went through the roof.
And the list reflected that complexity.
Absolutely. Broken access control surged. Why? Because now you had to manage authorization across maybe dozens of tiny separate services, APIs everywhere, lots of places for things to go wrong. And we also finally started waking up to the risks in the environment itself. Vulnerable, container-based images, misconfigured Kubernetes, the stuff running the application became a prime target.
Okay, so if 2017 was about fragmentation creating complexity, it feels like the 2025 list is saying, okay, we haven't really mastered securing that complexity yet.
That's a good way to put it. The 2025 candidate definitely focuses more on root causes, these big architectural issues, rather than just symptoms. Take AO1, broken access control. Still number one. Still
a king. It just won't go away, will it?
Nope. It held the top spot in 2021, and it's still there in 25, affecting, 3.73% of tested apps? The reason it persists is that sheer complexity we talked about. Every microservice, every API, another potential failure point for who gets access to what.
And it's evolved too, right? With SSRF being included now.
Right. That's a key update in the 2025 list. Including server-side request forgery under AO1 acknowledges that access control isn't just user to server anymore, it's also server to server, preventing attackers from making the server itself reach out and attack other internal systems. Lateral movement.
And this idea of agentic AI amplification, that sounds like a whole new level of scary for access control. How is that different? Isn't it just another way authorization can fail?
Well, yes and no. The failure might look similar, bad permissions, but the actor is different, and that changes the game. Before, it was a human mistake exploited by a human attacker. Now,
An AI agent.
exactly. Imagine an autonomous AI agent. If it has bad permissions, a broken access control, it could potentially start pulling massive amounts of data or changing critical systems on its own. No human needed to drive the attack second by second.
Wow. The speed and scale?
Exponentially higher. A human needs time to poke around, figure things out. An AI agent working autonomously, it could do immense damage almost instantly. That's the amplification risk.
Okay, that definitely sets a worrying stage for the next big mover you mentioned. AO2, security misconfiguration. Jump from number 5 all the way to number 2. That's the biggest leap on the list.
It is. And it's the clearest signal that infrastructure is the attack surface now. 3% of tested applications affected.
Yeah.
It's just the sheer volume of settings in cloud environments, especially multi-cloud, it's overwhelming.
And infrastructure as code makes it worse.
It can, yeah. IAC is powerful, but a mistake in one template, boom. It gets replicated across potentially thousands of resources instantly. And Kubernetes misconfigs.
Yeah.
They're a goldmine for attackers, often leading to complete cluster takeover.
The numbers are pretty stark, too. Something like 83% of orgs had a cloud incident in 2024, and misconfigurations were involved in almost a quarter of them.
That sounds right. And the cost, what was it? Over $4 million average per misconfiguration incident.
$4.24 million, yeah, that's staggering.
It really is. $4 million bucks. It just screams that doing this manually checking configs by hand, it's just not viable anymore. The speed, the complexity, the risk. You need automation, continuous checking.
Which brings us neatly to managing that risk. It's clear you need that automated posture management. And we should thank our sponsor, cloudassist.vibehack.dev here, because that's exactly what they help teams do, assess and fix these cloud configuration risks continuously before they turn into that multi-million-dollar headache.
Absolutely critical tooling for AO2, which then leads us to AO3, software supply chain failures. It's basically the new perimeter, wouldn't you say?
It really feels like it. It's not just about checking your dependencies anymore, is it?
Oh, not even close. It's the whole life cycle now. Compromised build pipelines, malicious packages snuck into public repos like NPM or PyPI, those tricky dependency confusion attacks. But it's a much broader threat landscape.
And the attacks are increasing.
Doubled in 2024, according to the sources. And the projected cost is insane. Something like $138 billion annually by 2031.
Wow. That XZUtils near miss really drove home how sophisticated these can be.
Didn't it just? That was a patient, multi-year social engineering attack targeting foundational Linux code. It really highlights the leverage attackers have. Think about it. The average app pulls in, what, over 200 third-party libraries?
103? Yeah.
Right. So one single compromised dependency upstream. It can ripple outwards and compromise thousands, maybe millions, of systems downstream. Your security is literally only as strong as your weakest link in that chain.
Okay, so if the pipeline is the perimeter, and we're deploying constantly, that brings us right back to DevSecOps. You can't have manual security reviews blocking thousands of deploys a day.
No way.
Yeah.
It just doesn't scale. It becomes a bottleneck. And frankly, developers will find ways around it if it slows them down too much. The sources point to a couple of categories that really show how security needs to shift left, become part of the foundation.
Like AO6, insecure design.
Exactly. This shows a kind of maturity, actually. We're moving beyond just fixing code bugs to preventing flaws at the design stage. Threat modeling, defining security requirements before you even write line 1 of code. That tackles the root cause.
So it's about architecting security from the start.
Precisely. The fact AO6 is actually dropping a bit relatively might even be good news. Maybe secure design thinking is slowly becoming more standard.
And then there's AO8, software and data integrity failures. That sounds like it targets the build process itself.
Yes, AO8 is fundamental. It covers things like insecure deserialization. But crucially, it calls out CI/CD, pipeline security, and integrity checks. If you can't trust the process that builds and deploys your software,
then nothing else matters.
Pretty much. Your whole security posture is built on sand. Verifying the integrity of your artifacts, your pipeline steps, that's non-negotiable in this cloud-native world.
Okay, we've traced the history, the shifts, the current crisis points in the 2025 list. Let's get practical. For you listening, what are the big impact controls? The things that give the most risk reduction, bang for the buck against these top threats?
Yeah, the sources are quite clear on this. There are basically 4 core controls that delivered maybe 80–90% of the value. The good enough solution, if you will.
Right, core control number 1.
Access and authentication. Simple but powerful. Enforce multi-factor authentication everywhere, ruthlessly. The data suggests this alone cuts risk by something like 40%.
40%, wow.
Yeah, it's the single biggest impact control. Hits AO1, AO7. If it also does only one thing tomorrow, it should be universal MFA. Seriously.
Okay, number 2.
Configuration management. This is your AO2 defense. Deploy Cloud Security Posture Management CSPM tools. Automate finding those misconfigurations. That gives you at least another 10% risk reduction across the board.
Number 3, gotta be the supply chain.
You got it. Supply chain defense. Implement software composition analysis, SEA tools, generate software bills of materials, SBOMs. You need to know what's in those 203 dependencies to handle AO3. Transparency.
Makes sense. And number 4.
Detection and response. You need visibility. Centralized logging, feeding into a SIEM security information and event management system. Why? To slash detection time.
Right, because breaches happen, but finding them fast matters.
Hugely. Good logging in SIEM can take detection time down from, like, months, the average used to be, over 200 days, down to hours or days. That minimizes the damage from things like AO9 and A10.
So these controls, MFA, CSPM, SCA, SIEM, automating them seems key. Embedding them right into the workflow. That sounds like DevSecOps orchestration.
It absolutely is. You can't bolt these on effectively at modern scale. They have to be integrated. That's the only way.
And that integration, that automation, that's where our sponsor DevSecOps.vibehack.dev comes in, providing platforms to actually enable that security automation and orchestration. It really is central to making DevSecOps work in practice.
Definitely. Which kind of brings us full circle, doesn't it? AppSec is this journey of constant adaptation. The 2025 OWASP list isn't just shuffling categories. It's reflecting a fundamental shift away from isolated code bugs.
Towards systemic architectural risks. The perimeter's gone, the pipeline's the new battleground. Security has to be baked in, foundational, not sprinkled on top.
Couldn't have said it better.
Yeah.
And, looking even further ahead, what might the 2028 list look like?
Yeah, what's the next frontier?
Well, the elephant in the room across almost all these categories now is AI, the AI security dimension. We're already seeing prompt injection. People are calling it the SQL injection for AI, basically tricking large language models.
That's getting a lot of attention. But it's bigger than just prompt injection, isn't it?
Oh, yeah. Think about AI model poisoning. That's essentially a new, very sophisticated type of supply chain attack, tampering with the models themselves or the data they're trained on. So the provocative thought for you listening is, how are you treating your AI models today? The ones you're building or using? Are you applying the same security rigor, integrity checks, access controls, monitoring as you do to your critical application code? Because that feels like the next great security challenge.
That's a really potent question to end on, especially with AI adoption moving so fast. Excellent point.
It's definitely something to think about.
Absolutely. Well, huge thanks again to our sponsors for helping us make this deep dive happen. DevSecOps.vibehack.dev, cloudassist.vibehack.dev, and find all their resources at www.vibehack.dev. We really appreciate their support.
Thanks, everyone.
And thank you for tuning in. We'll catch you on the next deep dive.